So, good morning, honorable present here. Department of Computer Science and Engineering, and course name 23 CST 207 Database Management System. Second year, fourth semester. Topic parallel database. So, we go for a parallel database before going to some agendas. First, what is introduction? Second, IO parallelism. Second, inter-query parallelism and intra-query parallelism. These are some agenda in parallel database. So we have going parallel database data can be partitioned across to multiple disks for parallel IO. So individual relation operation. For example, I'm using left join or right join. First I left join. First I compare to uh, um, to a table, and first I have first table I have A, B, C. Second table only A and B is available, and compare one by one which one is available. You can take the value. If not available, you can space. We can using of left join or right join. This is a way to comparison of individual relationship operation. For example, sort and joining operation aggregations can be executed in parallel method. So data can be partitioning, and each processor can work independently on its own partition, and query are expressed in high-level languages. SQL translate to the relational algebra and makes a parallelism easier, and and different queries can be run in parallel with each other, and concurrency control takes care of conflicts, and thus the database naturally link themselves to parallelisms. So this is a second IO parallelism. It's a reduce the time required to reduce the relation from the disk by partitioning, and second the relations on multiple disks. So one of the example, you take a architecture concept and hazards. So first hazards we have implemented in example hazards. First instruction can enter into the first one, and second instruction can first instruction can go to second process. The second instruction can enter into the first one. So we simultaneously working and within a 7 minutes. At the same time, you can using of different sectors. The first instruction complete in 7 minutes for all process after enter into the second. So we have some more time can be required. So if you have implement IO parallelism, easily complete within a time period to execute process in the relation from the disk by partitioning, and relation and multiple disk, and horizontal partitioning tuple of relation are divided among the many disks such that each tuple reside on disk. And partitioning technique, we example round robin techniques, number of disks equal to n, and send ith tuple insert into the relation to the disk ith mode of n. Hash partitioning, choose one or more attributes as the partitioning attributes, and choose hash function h with a range of 0 and n minus 1. So let I denoted results hash function h apply to the partitioning attribute value of the tuple, send tuple to disk I. So this is a inter-query parallelism. So in query and transaction execute in parallel with one another. They increase the transaction throughput and used to primarily to scale up the transaction processing system to support large number of transactions per seconds. Easiest from form of the parallelism to support, and particularly in shared memory parallel database. And because even sequential database support and concurrent processing, and more complicated to implement it on disk, implement the on shared disk or shared nothing architecture. Locking and lodging must be coordinated by passing message between processor, and data in local buffer may have been updated to another processor, and cache concurrency has to be maintained. Read and write to data, and buffer find the latest version of data. So this is a intra-query problem. Execution of a single query in parallel on multiple processor disks and important for spending of time longing running query, and two complementary form of the intra-query parallelisms. One is inter-operation parallelism, second intra-operation parallelism. Parallelism is execution each individual operation in query. They execute different operation in query expression in parallel. The first form select the better increasing parallelism because the number of tuples processed by each operation typically more than number of operation in query. Thank you.